Okay, now we look at exponential growth models. We're going to only look at exponential growth here. Exponential growth models will be increasing when you look at the graph. They're going to have the form y equals some constant greater than 0, so some positive number, times b, which has to be bigger than 1, the way this is defined, to the kx power, where k is positive. So greater than 1, positive, positive. As we discussed earlier, this will not have an x-intercept. It will never cross the x-axis. It will get down and hug it down here at the end, but it won't cross it. The y-intercept, instead of being 0, 1 here, because we have a constant multiplier of a in front, the y-intercept will always be at 0a. The domain is still all real numbers, and the range, of course, is our positive y values. Because that graph will never touch, it just hugs that x-axis. Our x-axis is the horizontal asymptote, and we have this kind of rounded J shape here. Now let's look at an application that deals with exponential growth. And we have talked about these applications before, but this is a compounded interest problem. We've got $4,000 invested for T years at 7% continuously compounded interest. The future value is given by this equation. S equals 4,000 e to the 0.07t power. Complete parts A through C. So the first part is to draw the graph. Okay, so we have to pick the graph from the choices. So I'm going to use my calculator to graph this. And I know it tells me to use a window of t greater than 15. So this is the current window that I'm using. From 0 to 15 for x, with the tick marks every 2 units apart, and 0 to 34,000 for y. And here my tick marks are 4,000 apart. I chose this because this looks like what the MyLabs Plus is using. I wanted my graphs to match MyLabs Plus graphs. So here's the graph I've got in my calculator, just by graphing that. And I see the only two that look similar to this is graph A and graph B. Okay, graph C and D neither look similar. So it looks like my graph ends up a little bit higher than the second line. See, if this was my tick mark here, it would be higher than that second line. So it looks like that's going to go with part A. So I'm going to match it up with graph A, and then use the graph to determine when the future value will be 8,000. Okay. So use the graph to determine that. Means that I want to go to my y equals screen, and now I want to know when that graph equals 8,000. So I want to know when they intersect. If I've already graphed the function, and then I graph y equals 8,000, I can see the intersection there, and then I would calculate the intersection. I'd move over to the intersection and press enter 3 times, and I would get that this intersects the line y equals 8,000 at about 9.9. So that means it's going to take about 9 years. Okay. So if it takes 9.9, about 10 years. So if, let's see, we would say that's going to take about 10 years to be worth 8,000. Now, part C says to complete the table. So we want to know when it's going to be oh, and I think down here I've got another one out here to this side, this one. I want to know the time when it's going to take to, if I want to know the time when that it's going to take for it to be 15,324.27 cents. Then I would do that the same way, except I would not put in Y2 equals 8,000. I would put Y2 equals this $15,324.27. When I calculate that intersection, I see that it would be 19. So it would take a little over 19 years. Now, if it asks you to complete a table here, it says complete the table, and we know the times. That just means all you have to do is calculate the time. So I'm going to go back in my calculator, and I've got my function in my y equals screen. I don't need the 8,000 anymore. I've got my function in my y equals screen, and then I'm going to go to my table. Now here it does ask for specific x values. So I could scroll up to there and get in 10 years. There's the exact value. I'd scroll over to it to get the exact value of $8,055.01. But then if I go on up to x equal 20, the calculator rounds it to put it in the table. So that 16,221 is the rounded value. If I move my cursor right on top of it, I get the real value is $16,220.80.